Hello. I'd like to talk today about function return values. Um, the idea of a function returning just one value is kind of how our world works, but um, not necessarily should have been that way, in my opinion, because functions should be able to return multiple values. And there's tricks to make them to return values through the parameter lines, the command to the input parameters, but is that really the right way to do things? Um, it's kind of the way we do it, but where did things go wrong? So I'm going to start here with this little template program. It's a console window. All it does is pop up a console window, and you press enter, and it exits. So what I want to do is I want to make a test. And I'll put it down here somewhere. I'm going to make a function. I'm going to call it ABS. Yes, function, I believe, for the absolute value of a number. So I'm going to take in, by reference, an 8-byte number. Okay. Now within this function, I just want to make the number return positive. So I'm going to first compare some number with 0, and I'm going to jump if it's greater than or equal to 0. In here would be negative numbers, and I'm going to use a built-in CPU operand called neg, and it will perform the 2's complement on a number and make it negative. So that is the function that we're going to do. But how do you return the value after it's been done? Well, because this is by ref, it's going to change some number into the result. That's how you change the input parameter. I don't think we want to do that. Let's go back and do it the old-fashioned way. Now I'm going to go ahead and declare a DQ here. It's not necessary. The compiler won't care. The reason it doesn't really care is because it can't force you to not do, like, it can't force you to, it can't stop you. Let's put it that way. What I mean is, I'm going to move into the REX register some number. So what that does is, this is the universal way of making a function that returns a value. You just put the value into the answer into the REX register, and then when you come back to the caller, they extract the answer off the REX register, and that is a function return. Like I said, whether we put DQ here or not, that's just kind of, for the programmer's reference on the caller side. But we can put anything we want to that REX register. So the DQ just tells you that you're returning an 8-byte number. So let's go up here and make the test. By the way, I could do subs too. A sub is just a function that doesn't return a value. But ironically, it still can't stop us from putting a value in the REX register. So it's kind of like it's kind of a rule or a law or a way of doing things, but it doesn't necessarily can't stop you from doing whatever you want. So let's kind of walk into this and see where we go here. I'm going to go up here to our test. I'm going to make a local variable. I'll make it another DQ. I like to do everything DQs. I'll call it my number. And I'm going to initialize it to be negative 1. Now I'm going to invoke my ABS function. I'm going to send it in my number. Before we do that, let's invoke prints.co.println. I got kind of over 3 different println functions in this module. There's one that I've wrote just a few weeks ago, about the 3rd one down. So what I'm going to do is I'm going to say ABS my number, and I get put in there my number. Okay, so that should print out the number as is, and I'm going to do the ABS, which should turn into a positive number. And then I'm going to print that again. Let's just kind of take that off like that. I don't know, that seems a little... Let's go like this. After ABS. How's that sound? My number. Okay, let's kind of take a look and see what we got there. Okay, my number, -1. My number after, -1. Okay, what went wrong? What went wrong is that our function returns the answer in RAX, and we never extracted it. So we have to move my number from RAX. Let's try that. There. Okay, -1 turned into +1. So that extra step there, when you're taking it off RAX, you don't ever see that in a program, because these 3rd generation programming languages all hide that from you. They kind of hide the registers entirely from you as well. You just say my variable equals function, and it's all done. It's just magic. But here in the assembly world, you can see that you actually are moving an answer into a register and then extracting the value off the register and moving it into the variable. So it's actually not just a one-step process. Let's do this again, and let's put the by ref in. And so now we're not really returning anything, even though it claims to be returning something. And let's take that off. And what that should do, you see that it did the same thing. It worked. And the reason for that is because this by ref means that the variable is passed in by address. And when it's by address, you can change the value of the variable. When you change the value of the variable right there in that line, you don't have to return anything. So that's an example of returning values through the RAX register, and also returning values through the input parameter list. So what I don't like about returning the values through the input parameter list is that you can make some bugs that are hard to find. Especially if you're passing in variables and they're automatically by default passing by address, and then you change the value, and then all of a sudden you got weird things happening. You don't know what's going on, and that's happened to me. But on the other hand, in the real world we live in, just getting one value out of a function kind of sucks, And a lot of times you'll end up, here's what I'll do. I'll set another parameter. I'll say return the answer. And then I put that RET in front of it, knowing that that's going to be a return value. But again, you're putting return values in the input list. It's not exactly right. So what this video is going to be about is the idea of returning values not in the input list. So we're returning it through the RX register. Now let's just say, there's a lot of functions that will say, returns a number and it's non-zero upon success. So on one hand, if it's a 0, there's an error, and you can use error trapping to then deal with that. And then on the other hand, you can return a series of codes that can mean different things on the return. So in a way, you're using that one return you get for multiple reasons. But wouldn't it be nice if you could just return another value, return two things, not using the input list? And that's what we're going to do here today. So what I want to do to get started is, what I want to do is return like a status code of some information, like was the input number positive, was it negative, was it 0? And this is just a simple function. I'm just trying to make an example. It's not a real world, something you can really use in the real world. So what I'm going to do is I'm going to create an enum called state. And I'm going to say positive equals 1, negative equals 2, and 0 equals 3. Well, when you have 0 equals 0, I don't know. Okay. So now down here in our our function, what I want to do is kind of look at it and change it a little bit. So, for example here, when we're on this line here, we know that it's a negative number. I want to say, I'm going to return a state in the RBX register. And I want to say state.negative. Likewise, this else condition here, let's say else jump equal. Jump equal is, so right now in the else condition it's going to be positive or 0. Now we're going to say the flag should be untouched still. So we can go ahead and jump right into another jump, and we're going to say jump equal. So now it's going to be the state where it's positive. And then we'll go else again, move RBX dot state dot 0. And that essentially, RBX will get changed, and will definitely get changed, and REX will definitely get changed. So now up here on the attest, we could say something like I don't know, let's do compare RBX, state dot negative. Oops. Jump. Not equal. To jump not equal this time. So if it's not equal negative, it'll jump. So invoke prints dot code dot println. The input was negative. Just being real simple today here. Else compare rbx comma state dot positive jump not equal. Just copy that down, make it a little quicker. The input was positive. Else input was 0. Okay, let's give this a run. See what we got. -1, 1, the input was 0. Oh, well, we got the wrong answer. Let's see what we have here. Okay, this is a classic mistake I've made multiple times. So you got to remember these registers are used everywhere by every function. So at this point in time on line 1.5, when the ABS function is invoked, RBX has our state intact. But then we run this function, and that function can and will trash every register that you think you have. So the RBX register state is only valid from here to here. So let's take this line out, put it down here, and that logic should run a little better now. The input was negative, so we have multiple problems here. Okay. Oh, sorry, the input was negative is the right answer. What am I thinking? The input was negative. Good. Good, good. I was thinking, no, it's not right. All right. The point of this whole exercise is that functions return one value. True. And the whole world is based off this paradigm. And it would be nice if they could return more than one value. And they're totally capable of doing it because you have a whole slug of registers that can return anything you want. It can return a pointer to a data structure. It has multiple variables. It can return a pointer to an object. It can return, and every single register can return something. But we don't utilize that because our function definition is just only built to be under the premise that you only can return one value, which is kind of like handcuffing you and kind of limiting you. So then me and tons of other people like me use the input list and pass by reference as a way of returning values from a function. And it works, and I do it all the time. I just think that the syntax could be changed such that maybe not even naming it a function anymore, such that it allows you to have multiple returns. And I don't know how that would how a third generation language would do that. It almost, I don't know, would be some inventive new syntax, but I really think that would be nice to have. So, if anyone else has any comments on this, I'd like to hear it. I'm not going to put this in my compiler because it's not really necessary. It's just one of those things that's kind of nice, and I've got other things I need to do to get this thing moving. But I'd like to know what people think about that. And any ideas of maybe what the syntax may look like if such a thing were to exist. And that's all I got for today. Thanks.